We've been working with lines, linear equations, and we've talked about three different forms: slope-intercept form, point-slope form, and standard form. So today we're going to talk about parallel and perpendicular lines. So our parallel lines are lines that have equal slopes. Their slopes are identical, but they cross the y-axis at different points. So they don't have the same y-intercept. If they had the same slope and the same y-intercept, they'd actually be the same exact line. So parallel lines have different y-intercepts but the same slopes. Where perpendicular lines have opposite reciprocal slopes, and they cross the y-axis at different points. So think about what opposite reciprocal means. If I have a slope of 1/2, or a half, the opposite is going to be a negative 1/2, and to do the reciprocal, it's actually a negative 2/1, or we can just write that as -2. So a 1/2 and a -2 are opposite reciprocals. So there's a few levels that you have to be able to complete for parallel and perpendicular lines. So the first level is to be able to state the relationship between two lines given. They can be in any form, whether they're perpendicular, parallel, or neither. So here are two lines that I give you. Y equals -1/3 x plus 5, and the other line is written in standard form, 2x plus 6y equals 12. So the first thing we need to do is find the slope. So this first one, we can see our slope clearly stated in y equals mx plus b form. Our slope here is a -1/3. So now we've got to see what the slope here is in our standard form. Well, we can put it into slope-intercept form and find out what it is, or we can use our formula for standard form to find slope, which is m equals -a/b. Right now our a is 2, so we put a -2, and our b is a +6. Then we simplify it down, and we have a -1/3. So we can see that the slopes are identical. So these are parallel lines because the slopes are the same. So for our second example here, we have one in standard form, -6x plus 8y equals 24, and slope-intercept y equals 3/4 x plus 7. Again, we're looking for our slopes to be able to tell, are they the same to be parallel, opposite reciprocals to be perpendicular, or neither to be neither parallel or perpendicular. They can both still be lines, of course, but they're not in that relationship parallel or perpendicular. So we have slope here. We'll look at -a/b. So right now we have a -a, so we're going to do the opposite, so that's going to be 6 over our 8, which reduces down to 3/4. And now we look at our other line here, and we have clearly 3/4 for our slope. And again, these are parallel because they are the same. So these are parallel lines to each other. If we were to graph them on a graph, they would run parallel to each other. Here are two written in standard form. So let's see if we can figure out what their slopes are. So we know for standard form we can use m is equal to -a/b. Right now our a is a +2, so we're going to put it as a -2 over 5. So the slope for this one is -2/5. Then here we have a -4, so our -a over b, and this simplifies down to -1/2. So we can see that -2/5 and -1/2 are not the same, so they can't be parallel, and they're not opposite reciprocals. If they were opposite reciprocals, we'd have a -2/5, and we would have a 5/2, but it would be positive, and that is not what we have. So these are neither, because they're neither the same nor opposite reciprocals. All right, try D and see if you can determine what they are. I'm going to use -a over b because this is in standard form. So -4 over -3, which gives me a +4/3 slope for this line. And then a -3 over a +4 is a slope for this one. So we can see that 4/3 and negative 3/4 are our respective slopes. They're not identical, so they're not parallel. So let's check to see if they're opposite reciprocals. So 4/3, its reciprocal would be 3/4. And to be opposite, because it was positive first, it would now be negative. Well, this matches. This is slope for this line, so they are perpendicular. They're perpendicular. This is the sign we use for perpendicular, or you can write it, which one means they hit each other or intersect at a perfect 90-degree angle when we were to graph them. So if we had a graph and we were to graph them, they are going to actually hit at a perfect 90-degree angle wherever they may be graphed at. All right, so here is a 4-star. So see if you can figure out if these are parallel, perpendicular, or neither. Pause the video and then return. So here if we look at y equals 3, we know this is in slope-intercept form, but we don't see an x, so we know that this slope is actually 0. And we look here and we see this is x equals 5. So we got to remember, how do we graph x equals 5? Well, those are ones that have a undefined slope. Or we think about it is written as no, or we can think about as a -1 over nothing. So let's graph these and see what we get. So if we were to find y equals 3, we would have it intersecting at the y-axis where 3 is and running horizontally. That's where we have a 0 slope. And then if we do the other one, the x is 5, we know it intersects at the 5 on the x-axis. And what do you know? They intersect at a perfect 90-degree angle. So this is a 0, and this is a -1 over 0, or a 1 over 0, whatever it may be. In this case, it's a 1 over 0. So if we think about, these are y's over x's. So if we think about where this point is here on the axis of the x, so if we look here, this is x is 5 right here. And if we think about how are we changing to go to our next point? Well, we just go up 1, but we don't run either way. We rise 1 or we go down 1. So our rise 1 is our 1, but we don't move left or right to get to the next point. We don't do that. So we have 0 movement. Well, 1 divided by 0 is an undefined number. So we know that if we have one that is 0 and one that is undefined, these are opposite reciprocals. So they are perpendicular lines. So this is one of those tricky special cases you need to pay attention to. So the procedure of being able to tell whether they're parallel, perpendicular, or neither is first thing you got to do is find the slope for each line. And then you compare the slopes. So the second level we have to be able to do is write an equation. So you have to be able to write an equation when given some information. So this first example, write an equation in slope-intercept form, which is parallel to y equals 3/5 x minus 4. So the first thing we want to think about is, what is it wanting us to do? So when we think about we were wanting to write something parallel, let's highlight those words so we remember what we want to do. So we're going to highlight the word parallel. It wants us to find something that's parallel. And we got to think, what does that mean? That means that they have to have the exact same slopes. So if we know that this one has a 3/5 slope, we're going to make sure that our new one is also 3/5. Now I know that I'm going to slope-intercept form, which I know is y equals mx plus b. So I'm going to plug in the same slope that I have into my equation of y equals mx plus b, plugging in my slope. And then I know that I'm going to go into this point here. So I don't know my y-intercept, but I do know that it has to go through this point of 5, 1. So that means when x is 5, that y has to be 1. So I'm going to plug them in, and I'm going to solve for b. So here I have 3/5 times 5. The 5's cancel out. I'm left with just 3. So I have 1 is equal to 3 plus b. And then I want to solve for b. So minus 3 minus 3, I have negative 2 is equal to b. So now I can put this back into my formula, and my answer would be y is equal to 3/5 x minus 2. So now I've created another line that's in slope-intercept form that is also passing through 5, 1. They have the same exact slopes, and they have different y-intercepts. So I know that they're parallel. Try this one. Write an equation in slope-intercept form for a line that is parallel. Again, we're looking for parallels. We're going to highlight our word they want us to do. To 3x, negative 3x, plus y equals 9. We have to realize that's in slope-intercept form. Standard form, and we're wanting to go to slope-intercept form, but it has to pass through to negative 6. So pause the video and try it. Alright, so I've already found out that my slope of my original problem is 3. And so I'm going to make my new equation, and it's got to be parallel to that. So I know that it's got to still have a slope of 3, and I know a point it has to go through to negative 6. Well, if I know a slope and I know a point, and it's not the y-intercept, I can use point slope. So y minus whatever my y is, in this case it's a negative 6, so I would say plus 6, a negative is a positive, is equal to the slope and x minus 2. Then I'm going to put it into slope-intercept form. So that is my y equals mx plus b. So I need to first go ahead and solve by distributing 3x minus 6. Then I need to get everything away from my y. So minus 6, and then I have y is equal to 3x minus 12. This is my final answer. It has, as we can see, the same slope as my original, so I know they have the same slope, they're parallel, and it has a different y-intercept. If I would put this one into slope-intercept form, I would end up with y equals 3x plus 9. I can see they have the same slope, but different y-intercepts. So I know that they're not the same line, but they are parallel to each other. Try this one. Write an equation in slope-intercept form that is perpendicular to 6x plus 16y equals 8, passing through 0, 4. So I found my slope in my original one to be negative 3/8. And I know I want it to be perpendicular. I've highlighted it there, which needs to be opposite reciprocals. Well, if this is negative, I know my new one's going to be positive, and it's going to be reciprocal of 3/8, so it's going to be 8/3. And it goes through a point of 0, 4. Well, I have a point and I have a slope, so I could use point slope, but if I pay really close attention, this point that I know is actually the intercept for the y-intercept. And I'm going into slope-intercept form of y equals mx plus b, so I literally can just plug in what I know. So y is equal to 8/3 x, and then my intercept is 4, so plus 4. And there you have a line that is perpendicular to our original. Notice they have different y-intercepts, and they are now complete. So our procedure for finding and how to create an equation. First thing you do is highlight what they're asking you. Are they asking you parallel or perpendicular? Then find the slope of the line that you were given originally. Then decide what do you have to do to that slope to make it match. If it's parallel, it's the same. Perpendicular, it's opposite reciprocal. Then look at a point that you were given. Then you're going to use that point and the slope, usually using point slope formula to get an equation, but occasionally they'll give you the point that is the y-intercept. So here is a challenge problem. I want you to pause the video and try this. So I need to have a parallel line. I found that my slope of my first line is 0, so I know my new one has to also be 0, and it has to pass through negative 2, 1. Well, what I know about having a 0 is that it's no fun. It's 0 fun. So y is 8 is going to go through up here at 8 on my graph, and I'm making one that is parallel to that. So it has the same slope. The point it gives me is going through -2, -1. So if I look at -2, -1, I'm actually at this point right here. So if I want one with the same, then I know it's going to go through here, which is horizontal, and the value of that is where it hits the y, and my y is a -1. So this new equation is y equals -1. Now, if you didn't see that, you could have used point slope, and you would have realized that y minus a -1 is equal to the slope of 0 times x minus a -2. You would then simplify that down. Y plus 1 is equal to 0 times all this would still be 0. And then you would put it into slope-intercept form. So minus 1, you would get y is equal to -1. All right, time for practice.